Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to the channel Chandan Physics. In this video, we are going to discuss behavior of real gases and its deviation from ideal gas equation. Let's begin. The ideal gas equation was derived by taking the kinetic theory of gases, means it is derived theoretically from the kinetic theory of gases. If we take n moles of an ideal gas, then the gas equation, ideal gas equation, or we can say that is the perfect gas equation, is PV is equal to nRT. PV is equal to nRT. P be the pressure, V be the volume, N be the number of moles of gas molecules, R be the universal gas constant, T be the absolute temperature. This is the ideal gas equation. It is the theoretical one. Actually, that is not possible, and that above equation does not hold good for real gases with complete accuracy. As you take complete accuracy, then it does not hold good in case of real gases. How? If we take at a low pressure or at high temperature, if we take at low pressure and high temperature, the real gas obey the ideal behavior. But in the above equation, as temperature tends to 0 or tend to approach 0 temperature, then the pressure will also approach 0. Temperature approach 0, then also pressure approaches to 0 from that of equation. Again, if the volume remains constant here, as temperature approaches to 0, ultimately pressure approaches to 0, here the volume remains constant. Also, if pressure remains constant and volume approaches to 0, when the temperature approaches to 0, that is the reverse case. Since we can't have the negative values for the volume or pressure, therefore lowest possible value of temperature is 0 Kelvin. So what it indicates, the above equation does not hold good for real gases with complete accuracy. And how we can convert a real gas into an ideal gas? So we have to take at high temperature and low pressure. So at low temperature, sorry, that wrong, at low pressure or either low pressure or high temperature, at very high temperature, the real gas obey the ideal behavior. That is the condition at which a real gas converted to an ideal one. The condition is at low pressure or at high temperature, the real gas obey that ideal behavior. So what should be the possibility, the value of temperature? What should be the possible value of temperature? So how to determine that one? that condition, if temperature tends to approach 0, then the pressure will approach 0 if the volume remains constant, and again if the volume approaches to 0, when the temperature approaches to 0 at pressure remains constant value. Since there will be no such negative value of pressure and volume does not negative, that is why we take the temperature is 0 Kelvin. So, here what is the possible case at which we take the temperature as 0? So, for that one we take the point, here we take the point as the point. The above equation, in the above equation, as temperature tends to approach 0, then the pressure will also approach 0. The pressure will also approach 0. If in that case the volume remains constant, if the volume remains constant, that is one possible case. Again also another possible case, if pressure tend to 0, if volume tend to 0, then ultimately temperature tends to 0 at constant pressure. So, here we write pressure remains constant if pressure remains constant, volume approaches 0, when the temperature approaches 0, as the pressure or volume can't be negative, since we can't have the negative values, we cannot have the negative values for volume or pressure. Therefore, what happened? The lowest possible value for temperature is 0 Kelvin. The lowest possible value for temperature is 0 Kelvin. At the lowest possible value for temperature will be 0 Kelvin. That is the important point from that particular equation. At these conditions, we can change the real gas into an ideal gas. These are the approach. how the 0 Kelvin temperature is the lowest possible case. That the reason, as you take the lowest possible value for temperature is 0 Kelvin. Now, the real gas, what type of equations or how we say that gases are under real gas category, means how they tend to approach a particular equation. So, many equations are derived to describe the pressure, volume and temperature relationship in real gases. There are so many equations regarding this, but the most famous and well known equation for real gas is Van der Waals equation, and that Van der Waals equation is P plus A by V square into V minus B is equal to RT, where A and B are constant. P with the pressure, B with the volume, R with the universal gas constant, T with the absolute temperature. A and B are constant, where A, B are constants. As we known all the things, and how the real gases are deviate from ideal gases. What is the basic reason on which basis we say that real gases are deviate from ideal gas or ideal gases deviated from real gas? What should be the difference in between these two? So, the intermolecular force of attraction between the molecules of real gases molecules is mainly responsible for the deviation from the ideal behavior. How real gases are deviated from that of ideal behavior? Due to that of intermolecular force of attraction between the molecules of real gases is mainly responsible for the deviation from the real gas behavior. That is the main cause, intermolecular force of attraction. There are two graphs. On the basis of these two graphs, we can easily detect how real gases are deviate from ideal behaviors. So, here we plot graph in between pressure and volume, pressure and product of pressure and volume. First graph, here with the pressure P in x axis and the product of pressure and volume in y axis. The deviation from ideal gas can be studied from the plot of the values of PV against the pressure. Here in this graph, we take a straight line here. This line be the ideal gas line. This line is the ideal gas line. Ideal gas line means the gas which obey the ideal gas equation that are under this line, that a horizontal dotted line for an ideal gas equation. However, for the gases like carbon monoxide and methane, if we take the graph for carbon monoxide, it will be this is for carbon monoxide CO, and methane, for methane the graphs looking like this. This is for methane CS4. The graph for carbon monoxide and methane, initially at low pressure PV decreases with the increase of pressure and after attaining a critical value, the product of PV increases, low pressure decreases, and gradually it will be increases as pressure increases, attaining the critical value here. At the critical values, after that of critical values, the PV increases. And the product of PV, if we take the gas like helium and hydrogen, for helium, this is the graph for helium, and if you take the hydrogen gas, this is the graph for hydrogen. Means the product of PV increases linearly with the rise of pressure. At first PV decreases with the increase of pressure, and after attaining that critical value, the product PV increases linearly with the rise of pressure. The hydrogen and helium at 273 Kelvin are less compressible at all pressures than that of ideal gas equation. This is how these gases are deviate from ideal gas equation. We can easily conclude from the graph PV versus P. Again, how the effect of temperature on the deviation from ideal behavior. We take another graph. X, Y. Here we take pressure P, pressure into volume in y axis, the temperatures T1, T2, T3, that is for T4. This is T1, that is T2, this line be the T3, that line be the T4, that line, this is T1, T2, this is T3, this is T4. Here the order of temperature as T4, the highest temperature as comparison to T3, T2, T1. T4 is less than T3, is less than T2, is less than T1. Means we take the graph PV versus P of a real gas at different temperatures. The dip in that curve, that is the dip in that of curve, becomes smaller and smaller as temperatures as in increases. T1 is the lowest temperature, then T2 is highest one with the T4 as comparing the all three temperatures. Means T4 is less than T3, is less than T2, is less than T1. Means T1 with the highest one. Oh, sorry to that. T1 with the highest temperature, T2, T3, T4 gradually decrease in temperature. Okay. At higher temperature T1, the curve is initially horizontal, that is very parallel to that of x axis, and that obey the ideal gas equations. But this temperature or that point is known as ideal temperature or ideal point, and the value of PV first decreases below that of ideal point or ideal temperature and then increases at the pressure gradually increases, whereas T4 is the lowest temperature, T1 be the highest temperature. So, what are the discussions throughout that of video lecture? So, here we discuss about the behavior of real gases and the deviation from ideal gas equations. So, here the ideal gas equation, these are the points on which basis real gas converted to that ideal one. This is the real gas equation. How the deviation occurred, that is the technical one, how the deviation actually occurred, and from these two graphical view we analyze how exactly the deviation looks like. So, with this useful and informative notes, let me wind up this session. Thank you.